Another triumph, RealView Imaging says that it has completed a successful clinical study in which doctors use live-action 3D holograms of their patients' beating hearts to help them during surgery. Experts say that this holographic technology could pave the way to a new era of interventional medicine. The innovation allows doctors to see parts of a patient's anatomy floating in mid-air during real-time medical procedures. Company officials say that now they've reached the point where science fiction has become a reality. Doctors are able to see and virtually hold vital organs in their hands, as well as an entire unborn fetus. A successful trial of the system took place at the Children's Medical Center in collaboration with the healthcare giant Philips. The system operates by using data analysis and the dense projection of light. Measurements and dimensions are produced by X-rays, MRI, or ultrasound images that are then used to create the hologram. The technology does not require special eyeglasses and creates real images rather than illusions.
And what that does is that gives you the patient's anatomy, the real patient's anatomy, in a position where it's hyper-realistic. You can see all of it. You can intuitively know where you are or what's going on inside that anatomy in real time. So you can use that to guide procedures. You can use that to understand better the anatomy that you want to deal with. So I think that because we deal with 3D patients, the imaging in 3D or 4D, because it works with real time, is a great advantage because we can see what's happening with the anatomy while we're doing the actual procedure. Doctors deal with patients. Patients are built of tissues and things that move. If we want to intervene and treat those things, looking at them as they actually are in real life, in real time, is definitely going to improve the way we perform our procedures, how successful we are in those procedures, and the time it takes to do those procedures. When I don't have to build it in my head from a couple of flat images, but I have the whole volume, then intuitively I can interact with the patient's anatomy. So I think the impact on clinical medicine in the wide diagnostic communication, understanding, and intervening, that's where it's going to be. You have the true patient's anatomy beating in the palm of your hand.
The system is involving two main aspects. One is computation, so it receives 3D data sets and computes the hologram. And then after the computation of the hologram, the system has an electro-optical part that actually propagates this light into space and reconstruct the image in free air, allowing the user to go and interact with the image. Unlike typical 3D solutions that usually require eyewear and create an illusion in space, in our case, we don't use any eyewear, and this is not optically, this is not an illusion, meaning it really reconstructs points of light in free space that are in full color, and since we are making these points dense enough, it looks for the user as a smooth image that is appearing in free space, and as I mentioned, allowing him to better understand the image and work with the image by literally touching it.
It's very intuitive because we are all used to our three-dimensional world, and instead of having two-dimensional cuts through the heart, we see the heart floating in front of us, we're able to cut through it, to touch it, to see the interaction between the device and the tissue around it, and it was really a wonderful, enlightening experience that we were never exposed to.
Turning to arts and entertainment and